Welcome back to Crushing Design Patterns in .NET. In our last episode, we learned how to dynamically add functionality with the decorator pattern. Today, we're exploring a powerful behavioral pattern that lets you turn a request into a standalone object. This simple idea unlocks incredible capabilities like queuing operations, logging requests, and, most famously, implementing undo/redo functionality. It's time to take control of our operations with the command pattern.
Imagine controlling your entire home with a single remote. Let's start by turning on the living room lights.
Now I'm using the very same button to open the garage.
The same button?
Exactly. Tomorrow, this same remote could control the television, or the ceiling fan, or even the curtains.
Let's see how our expert Arohi uses this pattern to build a flexible remote control for a smart home. Arohi, welcome. Today's scenario is for a simple smart home remote control. The remote has a single programmable button. We need to be able to assign different actions to this button at runtime. For example, one time it might turn on a light, another time it might open the garage door. Furthermore, we need the ability to undo the last action performed. How would you design the system? What's the initial problematic approach that might seem tempting here?
The naive approach would be to have the remote control class directly call the methods of the devices it controls. You'd see a big if-else or switch statement inside the button-pressed method. This is a classic coupling problem. The remote control is tightly coupled to every single device, light, garage door. To add a new device, like a stereo, we have to modify the remote control class. And implementing a generic undo feature here is almost impossible because each action is different.
At first, this design seems simple. One button controls the light,
Interesting.
then we change it, and now it controls the garage.
Wow.
Now let's add the television. Now the ceiling fan. Now the smart lock. Every new device requires another modification, but everything still works.
But every new device forces us to change the remote.
And implementing a generic undo operation quickly becomes much more difficult.
So the remote is becoming responsible for everything.
Exactly. That's the real problem.
How does the command pattern solve this problem by encapsulating a request?
The command pattern's core idea is to encapsulate all the information needed to perform an action into a single object. This command object decouples the object that invokes the operation, our remote control, from the object that knows how to perform the operation, the light or garage door.
Instead of teaching the remote every possible action, we simply give it one command.
I didn't need to know how it worked.
Exactly. The remote simply executes the command. The button never changed. Only the command inside it changed.
So the remote stays simple.
Exactly.
What are the key components of the command pattern?
There are four main roles. 1. The command, an interface that declares a method for executing an action, usually called execute, and often an undo method as well. 2. Concrete commands, the classes that implement the command interface. Each one is bound to a specific receiver and knows how to trigger an action on it. 3. The receiver, the object that performs the actual work, for example, light, garage door. 4. The invoker, the object that holds a command and asks it to execute when the time is right, our remote control.
Let's begin with the simplest participant.
Okay.
This remote only knows one thing: how to execute a command.
This small card contains everything needed for one specific action. We call this?
The command. The remote didn't turn on the light.
Exactly. The light performed the work. That's the receiver. Same remote, same button, different result.
So every command represents one specific action.
Exactly. That's a concrete command.
Now that we've seen how the command pattern works in the real world, let's translate that idea into C#. What does the I command interface and the receiver classes look like?
Remember our command cards? Each card performed a different action, but they all fit into the same remote because they followed the same shape.
Notice something important. Every command looks different, but they all fit into exactly the same remote.
The remote never changes.
Exactly. Only the command changes.
Different commands. Same structure. That's exactly what an interface gives us.
In C#, we achieve exactly the same idea by defining a common interface called iCommand. Every command in our application must implement this interface. The execute method tells the command to perform its assigned action. The undo method reverses that action whenever it's possible, allowing features like undo and redo to be implemented consistently. Next, we define our receiver classes. These classes contain the actual business logic. They already know how to perform their own operations. They simply don't know anything about the command pattern yet. For example, the light receiver knows how to turn the light on. Similarly, the garage door receiver knows how to open. Notice that these receiver classes are completely independent. They're simply responsible for doing their specific job. In the next step, we'll connect these receivers to our commands without changing their existing implementation.
Now, how do we create the concrete command classes?
This is the core of the pattern. We create a command class for each action we want to perform. For example,
This command holds the receiver it needs to perform the action.
So the command tells the receiver what to do?
Exactly. And we can do exactly the same thing for another action.
Same remote, different command.
Exactly.
light on command. It holds an instance of the receiver, light, and implements the execute and undo methods.
How does the Invoker, our remote control, change to use these commands?
The remote control becomes incredibly simple and completely decoupled.
The remote doesn't need to know what device it's controlling. It simply executes the command.
So the remote doesn't need to know whether it's a light or a garage.
Exactly.
And the remote can remember the last command it executed. That's what allows us to undo it.
It no longer knows anything about lights or garage doors. It just holds an iCommand object and a history of the last command executed.
How does the client code set up the remote control now?
The command is now programmed into the remote.
And the remote executes it.
The client is responsible for wiring these pieces together. It creates the receiver, creates the command, and gives that command to the remote. Now we reprogram that same button with a completely different command.
Same remote, different action.
Exactly.
We can change the button's entire functionality at runtime simply by passing it a different command object.
The client code is now responsible for wiring everything together. It creates the receivers, creates the specific command, and then gives that command to the invoker. We can change the button's entire functionality at runtime just by passing it a different command object.
What are the main benefits of using the command pattern here?
The orange card activates the lighting preset.
Yeah, and now simply by swapping the command card, the same button will open the garage door. And just like that, the stereo command is added. Would you like to try it?
Absolutely.
I've arranged the commands here: lights, garage, stereo.
All right, let's run the sequence.
The benefits are immense. 1. Decoupling. The remote control is completely decoupled from the devices. 2. Extensibility. We can add new devices and commands without ever touching the remote control class, adhering to the open/closed principle. 3. Undo/redo functionality. As we've seen, implementing undo becomes trivial. We just call the undo method on the last command. We could even store a history of commands in a stack to implement multi-level undo. 4. Queuing and logging. Since commands are objects, we can store them. We could put them in a queue to be executed later, or serialize them to a log to record all the actions taken in the system.
This seems very powerful. Where else is this pattern commonly used?
It's everywhere in modern software. Think about a text editor, every action you take.
Every action can become a command.
The editor can execute these commands and keep them on an undo stack.
The most recent command is undone first. The same idea is useful for task queues, workflows, and systems that need to record operations.
Typing a character, making text bold, pasting can be an object that implements an I command interface. The editor just executes these commands and pushes them onto an undo stack. It's also fundamental to task-based systems, transactional workflows, and any system that needs to queue or log operations.
In a modern .NET application, would you use a library for this or implement it by hand?
For a simple case like our remote control, implementing it by hand is a great way to demonstrate your understanding. However, in larger, more complex applications, you would typically use a library that has a built-in mediator or command bus. Libraries like MediatR are extremely popular in the .NET world. They provide a sophisticated pipeline for sending command objects and handling them, which is a more advanced implementation of this same core idea. Mentioning MediatR in an interview shows you are familiar with modern, real-world .NET architecture.
Arohi, that was a fantastic explanation. You've perfectly shown how encapsulating a request as an object with the command pattern can unlock incredibly powerful features and lead to a clean, decoupled design. If you now feel ready to take command of your application's operations, give this video a like and comment below with a feature you'd love to add undo functionality to. And don't forget to subscribe to the .NET Way. In episode 10 of Crushing Design Patterns, we'll explore how to define the skeleton of an algorithm in a base class, but let subclasses override specific steps. It's time to master inheritance with the template method pattern. Thanks for watching. We'll see you in the next episode.